Now let's integrate this stuff. So if you want to integrate this stuff by yourself, please pause the video and try it out. Now let's have a look. To solve this integral, there is a basic knowledge that you will be needing. So the basic knowledge of basic mathematics, let's say, right? Now, as you know that square root of x times square root of x is equal to x, and square root of x can be represented as square root of x times 1, and that can be written as square root of x times square root of 1. Now, in every pieces of square roots, I have included times 1 so that it will be easier for me to break down each and every part of that square roots, cubic roots, fourth roots, and fifth roots into different terms. So that is done in the same way as root under x times 1 is equal to root under x times root under 1 is done. So now let's go to another slide. So after you just separate every terms, you will get a kind of this kind of a term. So after you get this kind of a term, now the life is very easier. The life of solving problem is very easier right now. So it's pretty easier to look at the patterns now. The patterns are forming very easily. So square root of x can be written as x to the power 1 by 2, right? Now, if you break down each and every roots, cubic roots, fourth roots, and fifth roots, you'll you'll be getting in this way. So x to the power 1 by 2 times x to the power 1 by 3 times 2 times x to the power 1 by 4 times 3 times 2. If you add further, you might get times x to the power 1 by 5 times 4 times 3 times 2. Now what I do is I multiply the denominators of the power term, which is 1 by 2 by 1. So every powers I'm gonna multiply it by 1, its denominators only. So I'll get this term. So x to the power 1 by 2 times 1 times x to the power 1 by 3 times 2 times 1. So that's a basic understanding that it's a factorial term. So after you write this kind of a factorial term, it's going to be a lot more easier now. Now let's see. Using the concept of exponents, if the exponents are of similar bases, like here it is x times x times x, it's the similar exponents, then you can add its powers, right? That I have done in the next slide. So this is the one. Now let's see the most incredible thing of Leonhard Euler. He was the greatest mathematician, and he just brought up the value of E. So there is a famous explanation that the value of E had been obtained by the expression that is given in the left hand side, which is summation of k is equal to 0 to infinity 1 by k factorial, where k is all the positive numbers. You can even use the negative numbers, but for now, right now, you just for simplicity, let's use the positive numbers. Now, this is a value of E. Keep in mind that this is a value of E. Now, let's see what comes next. Let's just simply expand the terms. So keep the value of 0, 1, 2, 3, 4, 5, and 6, and so on and so forth. So you might be getting this kinds of expression. After you plug in the values, you will get this kinds of expression. And as 0 factorial is equal to 1, so 1 by 0 factorial is equal to 1. So we can write it in this way. So 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial plus 1 by 5 factorial, and so on and so forth. I haven't written so on and so forth as it is represented by dots. I haven't mentioned any dots after 1 by 5 factorial, but you have to keep in mind that it's an infinite series, and when it converges is the value of e that comes out magically. Now let's see, we only need 1 by 2 factorial terms, right? So 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial, and so on and so forth. We don't need 1 plus 1 by 1 factorial. As 1 by 1 factorial is equal to 1, that means if 1 plus 1 is equal to 2, then we have to subtract 2 from the equation. So after subtracting 2 from this large equation or large numbers, we get this: e minus 2 is equal to 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial plus 1 by 5 factorial, and so on and so forth. Now it's simple. Now just integrate x to the power e minus 2 term, right? So it's just simple. You'll get this. So after you integrating this stuff, we get this: x to the power e minus 1 by e minus 1 is the final integration of this equation. So if you are more interested in this equation or of its graphs, then here it is. This is the graph of x to the power e minus 1 by e minus 1. So yeah, this is it. This is the final equation that can be taken out from this integration. And yeah, good luck.